past completing the square. You don't need any notes yet. I want your full, entire attention. You can solve this with no problem. How do I solve this? No. Well, you could subtract. There's a couple different ways to do it, right? You could, I heard subtract 9, then it would be x squared minus 9 equals 0. Then you'd have the difference of two squares. What's another way to do it? Take the square root of both sides, plus or minus. So I would have x equals plus or minus 3. How about this one? How do I do this one? How about the same method? Take the square root of both sides. Right? That would cancel that square right there, and you'd have x minus 2 equals plus or minus 3. Okay, so this is where we're going. And you actually already know how to do that one as well. Can anybody see the squares in there? Remember I told you what's the first thing you always look for? GCF. What's the second thing you always look for? Squares. There's a square here, and there's a square there. Is this a perfect square trinomial? Let's look. X and X, 2 and 2. Since this is plus and this is negative, does that work? Yeah? Negative 2x and negative 2x makes negative 4x. So this is something you should have recognized from the beginning. This is x minus 2 squared equals 9, and then we are right back to here again. Take the square root of both sides. Okay, that's the direction we're heading, in this direction. All right. I'm going to show you one more thing with this. Let me show you an area model here. How many of you have worked with algebra tiles before? Okay. One? In algebra 1? All right. So this is an x squared negative x, negative x, negative x, negative x. This is what we're going to create right here. Okay, so if this is an area model is like a multiplication chart. So x times x is x squared. Okay, so I could have done it this way. Negative 1, negative 1. Negative 1, negative 1. X times negative 1 is negative x. X times negative 1 is negative x. What goes here? What would each one of these be? Okay, thank you. Brianna. Negative 1 times negative 1 is positive 1. So you'd have 4 positives in there. All equals 9. We're going to create these right now. Okay. X squared plus 2x plus something. We don't know what that something is. We're going to create a square. So if this is x squared, I have 2 x's and I want to split them up. There's 1 x there and 1 x here. What is missing here to complete the square? 1. Let's try another one. X squared. This time I have 4 x's. There's an x and there's an x. Bless you. There's an x and there's an x. What do I need to complete my square? What would go here? The 2 by 2, right? I'm missing a 2 by 2, which is 4. How about this one? X squared. I've got 6 x's. What am I going to do with 6 x's? Split them up. So I've got 1, 2, 3 on this side. 1, 2, 3 on this side. What would complete this square? The 3 by 3, right? 9. Why don't you try these? Okay, so Jose, what'd you get for this one? 36? I'm going to shorten it a little bit. X squared, if I split 12x, negative 12x, it's negative 6x and negative 6x. So what would complete that square, Jose? 36. Let's see. Brian, what about this one? X squared, I split it up to negative 5x and negative 5x. What would complete this square? 25. Good. Let's see. Who else? Brandon. This is negative 10x and negative 10x. What would complete this square? 100. Okay, so somebody tell me the pattern. What are we doing each time? We are splitting it in 2 or dividing by 2.
Half of being squared.
And conceptually, we're dividing by 2 and then squaring. Right? Splitting it in half and squaring it. Splitting it in half and squaring it. The whole point in this exercise is that you should never have to remember that it's b divided by 2 squared. You should be able to visualize the fact that you're splitting it in half and squaring it. Splitting it in half and squaring it. All right. Let's see. Now you're going to do whiteboards with these. Okay, so what would this one be? 16. And this one? 1, right? And this one? 4. And this one? What do you guys notice about this? Always. Always positive. Right? Can you go as far? Hold on, let me make sure if I have it later. Can you go as far as to actually put this into a perfect square for me? What would this be? X plus what? X plus 4, because 4x and 4x would make 8x. Why did I put 4 here? That was strange. What about this one? X what? X minus 1. X plus 2. And this one? Minus 7. Are you seeing the pattern? By actually creating the squares? So if you wanted to, you could even write this like this. Is this easier? 4 squared, 1 squared, 2 squared. Then it matches. 7 squared. Right? I'm sorry?
I just never thought about it that way.
That's exactly what it is, right?
It is.
Did I just teach you something? It's a miracle!
A little bit of math here.
Okay. Well, what about here? How would I solve these? Square root. That would be x plus 3 equals plus or minus 3. Got this one? equals plus or minus 0, but you don't have a plus or minus of 0, right? It's just 0. And this one? Would be, what is plus or minus 2 root 2?
Yeah,
Okay. Alrighty, make sure you've got some of this. I mean, I don't expect you to write all of them down, but enough so you can see a pattern. Let's look at these. What do I do with this? Okay, see anything? I see squares. I see a square here and a square here. So what would this be? X what? X plus 2? This is actually also a square. Isn't it 1 squared? 1 times 1? Now what would I do with it? Square root it. So it's x plus 2 equals plus or minus 1. Your turn. Try this one. At this point, I should probably finish this, though, right? This would be x equals 1 minus 2, and x equals negative 1 minus 2. Negative 1 and negative 3 would be my solution to this. Here's my point also. You should also now be able to visualize that. Visualize it as an x squared. How many x's are on this side? Negative 5x and negative 5x. For it to be a perfect square, how many does this have to be? And that works, right? You should be able to see it. It completes a square. When I first saw this done this way, I thought it was so cool because completing the square is actually completing a square. If you think about it. It really, truly is. Why they call it completing the square?
I don't believe it.
Okay, so in order to do this one, it would be x minus 5 squared equals 3. Take the square root of both sides, and you get x minus 5 equals plus or minus root 3. Solve for that, and you get x equals positive 5 plus or minus root 3. Questions so far? Anybody? Awesome. Let's get going. What if C doesn't work? Negative 7 is not a perfect square. What would be a perfect square? 9, right? All right. So there's 2 ways to go about this. If you really want to be conceptual, you could figure out what you got to add to both sides to make that number 9. No, how much would you actually have to add to both sides to make a positive 9? 16. You'd have to add 16 to both sides. But I'm not going to ask you to do it that way. But to me, visually, if I added 16 to both sides, wouldn't I have a perfect square?
Yeah.
So if you would like, for some of you that would like to think outside the box, like Dominic, maybe that'll push you a little bit more than what you used to do, because you already told me, I heard you, you add 7 to both sides, okay? You could, or do you see what I'm saying? Or you could add 16 to both sides, and then you'd have your perfect square, right?
Sure. Usually then they can do the first way you can do it.
Because it's procedural, and that's what we've been told to do it over and over again. But if you think outside the box, am I right? Yeah. Okay, so I don't want the negative 7. I'd rather make it 9, right? So I'm going to move 7 to the other side. So I have x squared plus 6x equals Because 6x is 3 x's and 3 x's, and to complete the square it needs to be a 3 by 3, which is 9. Right? Okay, so are all those legal moves? Can I add something to both sides? So now I've got x squared plus 6x plus 9. So this would be x plus 3 squared equals 16. Isn't that what I said you could have added to both sides? 16? Or what Ryan said you could have added to both sides? How many of you would rather just skip that step, moving the 7, and just add something to make it 9? No? I think it's easier, but I'm going to do it the way most teachers do it, and I'm going to add it to both sides so that I don't lose anybody that's already seen it this way. Okay, so now what do? Take the square root of both sides, and I get x plus 3 equals plus or minus 4. Keep solving this. Is x equals positive 4 minus 3, and x equals negative 4 minus 3. X equals 1, x equals negative 7. Copy that one down and then do this one for me. Check it with your shoulder partner to see if it looks right. I'm going to put this in a different color. And like I said earlier, is this factorable? X squared plus 6x minus 7. Is it? X and x, 7 and 1, positive 7, negative 1. Does that work? Positive 7, negative 1 makes positive 6x. Let's keep going. X equals negative 7, and x equals, when you switch to 0, and x equals 1. Isn't that what we got? The same thing. I really like completing the square because when you factor, it may not be factorable, right? Because it could have a square root in there. This method, you can go ahead and you can solve the ones that are factorable and not factorable. Correct? Wouldn't it also work if you had imaginary? Yeah? It will. It will always work. Okay, let's try this one. So is this a perfect square trinomial already? Is it? I'm going to argue that it's not. How come this is not complete the square right here? Can you tell me by looking at it? Because it's negative. Remember, every single time we complete the square, right, there couldn't possibly be a negative in there. Because negative times negative is positive, right? All right, so what would I have to add to both sides to make that a perfect square? 8. But if you don't want to add 8 and you want to just do it the traditional way, you would say, okay, I'm going to add 4 to both sides, move c over, right? Which is x squared minus 2x. Now, what does this have to be a perfect square? One? What do you guys think? Oh, we said add 4 to both sides, or add 8 to both sides, because we were trying to make it positive 4. We were making a mistake, right? My point is this looks like a perfect square when we're first looking at it, right? But it wasn't. We had to add 4 to both sides. It should have been 1, so we shouldn't have added 8 to both sides. We should have added 5 to both sides. Sorry about that. Okay, so we have to make this 4. Sorry, 1. So now it's my perfect square. X minus 1 equals 5. This is what you guys got. X minus 1 equals plus or minus root 5. So my two roots are 1 plus 5 and 1 minus 5. Questions on this one? All right, let's go through some steps. Put the steps in your own words. So this is what your homework is going to look like. All right, so what's the first thing that we do? I heard it. Move. Move what? I'm not going to call it C, though. I'm going to call it the constant. C is what's a perfect square, right? What we're going to do is we're going to move this over here because it's not a perfect square. So move constant. So when I move the constant to the other side, I get x squared minus 4x. I'm going to make it a perfect square equals 5 plus. I like to put my boxes there because it reminds me that I've got to add it to both sides, okay? All right, now what? What's my next step in your own words? What do we do now? We got to find that square, right? Find our square. Or find C. So how do we do that? We take negative 4, we divide it by 2, and then we get negative 2 squared. I leave it just like this. Okay, now what? Now we got to add to both sides. Add our C, right, to both sides. That gives me x squared minus 4x plus negative 2 squared equals 5 plus what? 4. Why would I leave it like that? Is there a reason I would leave it like that? How come, Brennan?
On my search one, I was putting it 4 as well.
You make it 4? You can make it 4 too. Here's the reason I like to do this though. My next step is to factor. And combine like terms. So when I do this whole thing, this whole factor, this answer right here goes right here. You guys see that? It's going to be negative 2, just like that. It's the square. I made a perfect square. Equals 9. Now what do I do? I heard it. Take the square to both sides. So when I do that, I have this plus or minus sign. And then finally, solve. Which gives me x minus 2 plus or minus 3. So x equals, call it out, 3 plus 2 would be 5. And negative 3 plus 2 would be negative 1. All right, make sure you have all that down. All right, why don't you try this one on your own? 1. All right, What's popcorn? Let's start with Russell. How much do you, Russell?
X squared minus 6x.
X squared minus 6x what? Equals positive 3. And I just put my boxes in here. All right, popcorn. Pick somebody. Okay. Okay, so how do we do that? Okay, what do we do with the negative 6? What do we do with negative 6x? Divide it by 2, so I'd have 3x's on this side, or negative 3x's, and negative 3x's on this side. What goes here in this box? Positive 9. See that? Okay, now what? Popcorn. Go. That's what I should have done here, huh? Add what? What am I adding to both sides? 9. Good. So x squared minus 6x plus 9 equals 3 plus 9. Popcorn. James. No, James. Samantha.
Oh.
X minus 3 squared equals 12. Good. Pick somebody. No? Good. So x minus 3 squared equals the square root of 12, plus or minus. Pick somebody. Let's just split it up now. X minus 3 equals what? It could be 12, or it could be 2 root 3?
Yeah.
Okay. So positive 2 root 3 and negative 2 root 3. Yes. So it's x equals 3 plus 2 root 3, and x equals negative 3 minus, sorry, it should be positive 3. Positive 3 minus 2 root 3. Yeah, you can do either way. Alright? Let's move on to this one. What's different about this one? It has something here. It's not any different. Same process, right? What's my first step going to be? 14 doesn't work, right? What does work? 25. Right? Right? Because when you take 10 x's and you split them up to be 5x and 5x, what is this going to be right here? It's going to be 25. C is going to be 20. Are you guys visualizing it now? Are you seeing it? So it would be x squared plus 10x plus our mystery C equals, when I subtract 14 from both sides, what do I have? 1. Now what? What's this step? Add 25 to both sides. I could leave it like this, x squared plus 10x 25, and this could be 5 squared, if I really wanted to make it that way, right? Then what goes in here? X what? Plus 5. Then take the square root of both sides. I think you guys are ready for your worksheet. So my two solutions are x plus 5 equals, does 26 break down?
No.
No? So it's just going to be positive root 26, and x plus 5 equals negative root 26. So x equals negative 5 plus root 26, and x equals negative 5 minus, what did I do? Root 26. Yes?
Would you just put x equals negative 5 plus minus?
Uh-huh. Yep. I'm just trying to go back and forth at saying this is two different solutions. I just want to make sure you guys see that. But yes, you can just put plus or minus. Questions? Can you do this on your own? All right. What are the different types of strategies to solve this quadratic equation? Factor. Could you factor this?
Yes.
Is it factorable? 5 and 1, 1 second. Negative, positive. It is factorable. What else could I do? I could do an X box. What else could I do? X box and factoring are the same thing, right? What else could I do? I could use the quadratic formula. What else could I do? Complete the square. What else could I do? Standard form. What do you mean by standard form? It is in standard form. We're missing one. I'm going to say X box and factor is the same thing. What am I missing? There's only one thing we're missing right now. What did we start off this chapter with? You don't remember? I could graph it. So tomorrow we're going to do all 4. All right, let me give you a worksheet.